All right, 2.5, we're going to take a look at inverse functions. So inverse functions is the ability to switch outputs and inputs. X and Y switch places. That's the whole idea of inverse functions. So when we're looking at an example of numbers, which is our first example, literally we're going to just swap the X's and the Y's. So this is a one-to-one function is where we're going to start. A one-to-one function for every element, a function for which every element of the range corresponds to exactly one element of the domain. So we'll get to the switching here in a second. So remember when we were looking at sets of numbers and asking ourselves, is it a function? Is it a function? Is it a function? What we did is we said, okay, does every element in the domain go to just one place over here in the range? Can I do it that way? Or does it break off and go to two spots? And if it does, it doesn't work. Well, one-to-one function is actually easier to work that out. Because if you're actually listing these, so let me actually list them. So my X values are 2 and -2. My Y values are 4. There's only one Y value. Yes? Yes. And so what you notice, if you're comparing these two sets, is that if you made an arrow, it would go like this, and that would be a function. But one-to-one has to have every item in the range also only having one item going to it. So one way to think about this is think about what happens if you were to get together with some friends. So let's say that you were to get together with some friends, and everybody has to pair off, and you're doing some ride at Frontier City. 2 people per ride, right? The only way this is going to work is if there's an even number, right? If there's an equal number of people in seat number 1 and an equal number of people in seat number 2. The pairing is only going to work. So this is only going to work if I have the same number of items in set 1 as I do in set 2, and this one doesn't have that. So this can't be a one-to-one function. So is this one one-to-one? And the answer, of course, is no. But if you notice on the next one, I have 3, 5, and 7. And then I have 2, -2, and 8. It's the same number, isn't it? And each one corresponds uniquely. So one-to-one has to do with this unique correspondence business. It's a unique thing. So when we did functions, we talked about the vertical line test, right? We shifted this vertical line along everything, and we said, does it pass that? Well, when we talk about one-to-one, we can actually talk about a horizontal line test. So the horizontal line test looks identical to the vertical line test, save for the word vertical, changing to horizontal, and it says a function is one-to-one if no horizontal line crosses through the graph more than once. So, for example, I think it's on the next slide, so let me let you write that down. I'm going to draw a picture of one that we've seen before. We saw it a couple class periods ago. It was the equation f of x equals x minus 2 in absolute values minus 1. And when we graphed it, this is a V graph. We were talking about that too, I remember. And when we graphed it, it looked something, I don't need to get it specific, but it looked something like this. For the purposes of our discussion here, that's close enough. And if we were working with this and we were looking at vertical line tests, does it pass the vertical line test? Yeah, so it's a function. It passes the vertical line test, absolutely. But does it pass the horizontal line test? No, it does not. And because it doesn't pass the horizontal line test, it is not one-to-one. So this is not one-to-one. And if you want to think those are terrible horizontal lines. Oh my word. Somebody should have said that. My paper's tilted. We'll go with those two. That's a little bit more convincing. Here's actually why. Whatever this y value is, it's the same height twice, right? So if I were listing numbers like I just did a moment ago, these are the same y value, but they come from different x values. That's actually why the horizontal line test works. Is because there are, in this case, 2 x values with the same y value. In essence, it's this picture. 2 x values, same y value. And that can't happen if a graph is one-to-one. So We're going to write down the definition of an inverse function, and then we will stop and the steps, because they're on the same slide. An inverse function of a one-to-one function, f, undoes the original function. Right? It's like opposite operations. So you're going to see things that used to be division and now they'll be multiplication. It used to be subtraction and now it's going to be addition. And the way we find inverse functions is what I mentioned earlier on. We switch x's and y's, and then we solve for our new equations y. So we will pick back up with examples of finding inverses when we come back to class on Friday. Have a great couple days, guys.